I'm in Cura, which is the program we're going to use to prepare the file for 3D printing. And similar to Onshape and other 3D CAD programs, we've got the axis origin here. So this tells us where the front corner of the table is. I need to get that stereolithography or STL file that I just saved from storage, get it in here, get it positioned and sized and sliced, and have a file prepped that I can then take to the 3D printer. So I'm going to click up here to open a file, and I believe that I put that STL file in the downloads folder. It's right there. Giving a file name that tells your name and what the project is very helpful for finding it when we get into the 3D printing part of this. All right, so the orientation is it has this standing up on its edge, which is true. It's the representation for how we drew the part. However, that's not really going to work out too well to try to 3D print. So what we want to do is we need to manipulate this a little further. The first thing I'm going to do is I'm going to get in and rotate this. Each of the three axes, X, Y, and Z, has a different color. And the idea is, think of it as like a hoop. And you can click on it and drag and spin around the axis in the path of this hoop. So the way that I want to rotate this to make this lay down, I need to spin it around the x-axis, which is going to be this red hoop here. And I'm going to turn that, and you can see the angle in degrees. I need to go 90 degrees. And when I let go, it's going to be suspended above the table surface, but it will drop. It knows that, and it's going to drop it on the table. And you saw it come down. It's slicing it, and it says it's going to take 53 minutes. Ideally, for our purposes, we want something that's going to be 20 to 25 minutes. A 53-minute print job just causes a backlog if we're doing these one at a time. I have a couple options here, but they all involve somehow changing the shape of this and making it smaller. So to resize this, I'm going to scale this, and I can drag these handles, which may be good for getting started and doing kind of a crude, rough start with it. However, I can also type in numbers here. I can go % of original size, or I can put an absolute number in millimeters. Every time I make an adjustment, it reslices it. I've made this thing so small that it's a 7-minute print job now. I might experiment with this a little bit and get this to where I can get it in the 20-minute range. So 42 millimeters, let's try 65. And it will proportionally rescale everything in the other two axes when you type in a number, either for percentage or for the absolute size. I've got a print job that's going to take 26 minutes to do, just guessing off the 65 millimeters. And that's fine. I can do that. Now, we use 0.05 inches for the thickness of everything. If you use differing numbers, and maybe the base was going to be overly thick or something, one of the things you could do is you can turn off uniform scaling, and I could independently alter the z-axis. So like in this case, instead of 2 millimeters thick, I could make it 3 millimeters thick. When I did that, you saw the change here, but the other two axes did not change at all. And that puts me up to a 41-minute print job. Well, I can turn the uniform scaling back on and maintain all the proportions, and I can leave that thicker with relation to the rest of it and make it maybe 55 millimeters to reduce the size a little bit. Now when I do that, the thickness drops off. Oh, I can put that back up a little thicker. And back at 26 minutes, let's get a little lower than 26 minutes. Let's go to 48 millimeters. And turn off uniform scaling and put that back to 3 millimeters. And see what happens to the slicing time. That's a 24-minute print job. With it being thicker, there's going to be no mistake about the detail on those raised parts. Quite honestly, that's raised up a little bit more than what's going to be needed for the kind of print that we want to do. I wanted to demonstrate that, but I'm going to go ahead and put that back. And then back to my 26-minute print job. So it's going to use about 1 meter of filament that weighs about 3 grams. All right. At this point, I am ready to export this file, save to removable, which is card F1, which is in the SD card slot in the front of the machine. file is saved, and it says it is okay to eject hardware. For our next video, we're going to go over to the 3D printer, and we're going to actually print this job.